Hopefully by now, you are comfortable with regular long division. In this lesson, we will look at polynomial long division, which is quite similar to the long division you already know. We'll start by looking at an example. We have 2x cubed minus 3x squared plus 4x plus 5 divided by x plus 2. The first thing to ask ourselves here is, what is 2x cubed divided by x? Note that we're not asking what is 2x cubed divided by x plus 2, we're ignoring the 2 for now. This is a key difference that comes up in polynomial long division. In other words, we're looking for something that we can multiply x by to get 2x cubed. The answer is 2x squared, which we write on top of the long division sign. Now, we multiply our divisor by what we've just written, 2x squared, and write the product underneath the dividend, again similar to long division. 2x squared times x gives us 2x cubed, and 2x squared times 2 gives us 4x squared. Next, we subtract 2x cubed plus 4x squared from the dividend. Keep in mind that both terms are being subtracted, which is why I like to place them in brackets. Before performing the subtraction, many students find it useful to distribute the negative from the subtraction among the two terms. A common mistake during this process is to only apply the negative to the first term, so a tip that you may find useful is to circle the sign of each term after you have applied the negative, like so. Now, performing the subtraction, 2x cubed minus 2x cubed gives us 0, and negative 3x squared minus 4x squared is negative 7x squared. Since the 0 is irrelevant, I'll just get rid of it. Now we carry down the next term, the plus 4x from above. From here, we can basically repeat the same steps until the division is finished. Again, we're going to ask ourselves a similar question to what we did at the beginning. What do we multiply x by to get negative 7x squared? The answer is negative 7x, which we again write above the long division sign. Now we multiply our divisor by what we've just written, negative 7x, and write the product underneath what remains of the dividend. Negative 7x times x gives us negative 7x squared, and negative 7 times 2 gives us negative 14x. Next, we subtract this product from what remains of the dividend. Again, using the brackets to remember that both terms are being subtracted. Before performing the subtraction, let's distribute the negative as before and circle the signs of the terms after the negative has been applied to make sure we get them both. Now performing the subtraction, negative 7x squared plus 7x squared gives us 0, and 4x plus 14x is 18x. Again, I'll just get rid of the 0. Notice that the first subtraction always gives us 0, which we can take as a sign that we're on the right track. Now we carry down the next term, the plus 5 from above. Here we are again, repeating the same steps as before. We ask ourselves, what do we multiply x by to get 18x? The answer is of course 18, which we write above the long division sign. Now we multiply our divisor by what we've just written, 18, and write the product underneath what remains of the dividend. 18 times x gives us 18x, and 18 times 2 gives us 36. Next, we subtract this product from what remains of the dividend, again using the brackets to remember that both terms are being subtracted. Before performing the subtraction, let's distribute the negative as we've done a couple times now and circle the signs of the terms after doing so. Now, performing the subtraction, 18x minus 18x gives us 0, and 5 minus 36 is negative 31. Again, the result of our first subtraction is a 0, which means we're on the right track. We've now got to the point where we can't multiply x by anything to get what remains of the dividend, negative 31. In other words, the degree of what remains is less than that of the divisor. This means that the division is complete, and the negative 31 is our remainder. Another cue that the division is complete is that the last term we added to our quotient, which is above the long division sign, was a constant term, that positive 18. To summarize what we've done so far, we have determined that 2x cubed minus 3x squared plus 4x plus 5 divided by x plus 2 is equal to the quotient that we have from above our long division sign, 2x squared minus 7x plus 18, plus some remainder, which we've determined is negative 31, and of course that is still being divided by our original divisor, x plus 2. To prove that this is true, let's test our result. To start, we'll multiply both sides of the equal sign by x plus 2 to give us what is known as the division statement. It tells us that our dividend, 2x cubed minus 3x squared plus 4x plus 5, equals some quotient, 2x squared minus 7x plus 18, times some divisor, x plus 2, plus some remainder. In this case, it is negative 31. To prove our quotient and remainder are correct, we will expand the brackets on the right-hand side of the equal sign and combine like terms to see if we end up with the same expression as we have on the left-hand side of the equal sign. 2x squared times x gives us 2x cubed. Negative 7x times x gives us negative 7x squared. 18 times x gives us 18x. 2x squared times 2 gives us 4x squared. Negative 7x times 2 gives us negative 14x. 18 times 2 gives us 36. And the negative 31 can come down as it is. Now, combining like terms, we circle the x cubed terms. There is only 2x cubed. It comes down as it is. Next, we'll box the x squared terms, negative 7x squared and 4x squared. Their sum is negative 3x squared. Next, we underline the x terms, 18x and negative 14x. Their sum is 4x. And finally, we'll put an oval around the constant terms, 36 and negative 31, which together give us positive 5. As you can see, the left and right-hand side of the equal sign are the same, proving that the quotient and remainder we found through polynomial long division are correct.